Hi, Stefan here with video 2 from my series to make a platform game in Codeskulptor using Python. Quite a long video this one's going to be, I think, so maybe an hour, so a lot to get through. If you remember from the last time, we have drawn some bricks on the screen and not really a lot more. We're going to move from that to having a player that can run around the screen and jump. Doesn't fall through bricks when he stands on them. First thing to talk about is just about the graphics. I have downloaded some player graphics, which I'm showing here. I've basically selected a few frames, which are the ones along the top, and then I just flipped them in paint.net and put them on the bottom. These are basically blocks of 64 by 64 pixels, so we can use X and Y coordinates to get the correct frame for whatever action. And just the actions are standing still, jumping, falling, and then 3 for running. Okay, so I put that on Dropbox, and the first thing to do is go and get a URL for that ping file. And we're going to go into our var class and just make a player image variable to load up this image. One of the advantages, we could attach all the images to the objects, to the player class, or to the instance of the player class. But if we load all our objects up here in our class var, we can very simply group them together and have a check to see that they're all loaded. So when we get lots of images in, we can run a check to see that they load and not start the game until all the images are loaded, which is quite useful. Okay, so as I said, the player size is going to be 64 by 64. Now, that's not where his feet are. His feet are about 3/4 of the way down the graphic. So when we're checking to see if he's standing on something, the points that we're going to check are going to be about 1/4 down from the halfway point and 1/4 either side. Okay, just something else I'm gonna set here is gravity. I'm gonna set gravity to 1 for now. That's going to be something we'll tweak as we go through. There's going to be a few variables that we're going to set in, like the speed that he runs at, and I'm just going to set to kind of quite round numbers, and then at some stage in the future can kind of tweak that. Okay, so let's make a class for player. Objects. It's going to be an instance of that, so we need an initializer, a constructor, whatever it's called, and I think that should take the position of the player, and that's about it. Then we can set that self.pos to be that position. We can set velocity as well, and acceleration. Now the velocity, I'm going to give him a rightward component to his velocity just to begin with. I'm going to have him appear at the top of the screen and moving, so he's sort of kind of jumped onto the screen. Okay, maybe I'll make that a little bit bigger, and then acceleration, there's going to be no acceleration initially. Any acceleration is going to be calculated in update and so on. So position, velocity and acceleration. Another thing we need to keep track of is the player's direction. We need this to see which row of sprites to use. I'm going to use 0 and 1 just so it's very easy to index into that, to kind of look for the center of that sprite. So 0 is right because the top line of that sprite is right. So let's just, maybe worth just quickly looking at that. The top line of sprites is facing right, so I'm going to call that 0 because it's 0 times his height plus half his height is where his center point is. And I'm going to call this left, I'm going to call 1 because it's 1 times his height plus the center point. And then if we chose to, if you wanted to show him what going up a ladder or something like that, his direction might be 2, then you could put another row into the sprites without affecting what we've already calculated. Okay. And then we want some Boolean values for what he might be doing. I'm going to say is moving, and that's going to be false initially. Is jumping, again, is false. And then is falling, why did I put capital S there? Is falling, I'm going to say is true, because he's going to kind of jump onto the screen. We're going to start him off above the row of background blocks. Okay. Another thing we want to set is a frame for animation, starting at 0, and that's just going to basically increment. Some friction value, a coefficient of friction, which you'll have seen all about in the class. We basically multiply the velocity by this every frame so that it kind of limits how fast the player can run and also slows them down when they're moving. And then I'm going to set a rate for which the player runs. That's going to start off at 1. I'll probably change that. Okay, so we need some methods on the player. We need an update. Just going to run every tick and just update position, velocity and that kind of thing. It's also going to do the checks to see if he's standing on the ground, if he's jumping, and set up some conditions around that. We want a draw, which is going to be responsible for drawing the player on the canvas and calculating what animation frame we're on. Also, just go left, go right, and we're going to have jump and stop, and this is just so we can call these. We can call this code from the button handler, so we don't have lots of complicated code in the button handlers. Okay. Okay, so now we have the skeleton of our class, our player class. Let's go ahead and in the game class, remember, which is holding instances of our game objects, we're going to create a player instance. I'm going to create that player on the left edge of the screen and just somewhat above center. So our height is 600 pixels, so about 200 pixels down, and we've given him a rightward kick, so he's going to come kind of flying onto the screen from somewhere above center. Okay, and then once that instance is created in the draw class, the main draw class in GUI, we're going to call player.update and game, not game, and draw, and that gets a canvas. Okay. So the main part of our update method for our player is gonna, there's two main parts really. One is updating position and velocity based on velocity and acceleration. So the X position gets updated by the X velocity. Same for Y. Then velocity X gets updated by the acceleration. Now these are Y, so these should be ones. And then we've got friction to take into account, so the zero component friction, zero component velocity is just multiplied by the friction factor every frame, and the same for Y. So that's one part of the update. The other part is to check whether the player is standing on on solid ground, and to check jumping and that kind of thing. So we're going to need a new method in the background class to check for collision. I'm going to write a method that checks 2 points simultaneously and returns true if either one of them is basically a box. So if there's solid ground at either of the 2 points that it's passed, it's going to return true. So what we're going to do here in the update class is we're going to create 2 points. And then we're going to do our collision check. Okay. So now at this point I want to go up to the background class and just create that method, which I'm going to call collision. It's going to take it's going to be called on the instance of the class because we need access to the bricks array, bricks list. And it's going to take 2 points, and we're going to run through a check. Okay, so let's say the result is false initially. Facile false, and just return. At the end we're going to return whatever the result is. So if we pass all our tests, we're going to change that result to true. So the first thing we need to do is take P1 and P2 and convert them from pixel coordinates into positions in the array where the boxes are. So I'm going to call those XP1, YP1, XP2 and YP2. And the way we do this, we take the X value of P1 and divide it by the tile size times scale. Now we'll run into, because our position might not necessarily be an int, because velocity and acceleration, the factors are all whole numbers that we're using now, but velocity is going to get multiplied by 0.9, so it's going to turn into turn into a float pretty quickly. So this P10, this point we're passing in, might not be an int, and since we want to use this as an index for our list of lists self.bricks, we need to cast this into an int. Okay, so that's the form that all 4 of these points are going to take. We're just going to create all 4 of those. The y is going to be p1 1, and it's going to use tile size 1. The same, and these are p2. These are points for p2. Okay, so we've got our 4 indexes for the list self.bricks, and we just then need to just check that either one of those xp1 yp1 or xp2 yp2 is not -1 -1. So because we're going to be indexing, and just for safety, and this is something to bear in mind, we just need to check that the xp1 yp1 xp2 yp2 fall within the range of the lengths of the list, fall into allowable index range. So self.bricks for the x value, and it's got to be less than the length of self.bricks, because as you know, if you've got an array, a list of size 10, you can't, there's no index 10. 9 is the highest index, so that's why that's a less than equal sign at the beginning and a less than sign after. And this is going to be sorry, that goes there, and this is xp1 that we're looking at here. So okay, so this is and, because all 4 of these have to be true, because we're going to be indexing with both. So we're going to say and I'm just going to go and clean this up, because it's xp1, xp2 is going to have the same test, then yp1 we're going to say bricks, and we're just going to take an element out of that bricks array, so element 0, and that's going to give us the y length of so yp2. Okay, so once we've figured out, that's basically saying, is that array safe to index into with those values, and if it is, and if it's not, it's going to return false. So if we pass it values, if the player is off the screen or outside, now hopefully we would be checking, we would only send it safe values, or we'd make sure the player is constrained in some way. But just in case it's not, we're just going to make sure that any check we do here is safe. And then all we need to do is say if self.bricks xp1 yp1, which if you look upwards, that's 0.1 essentially, but converted into the array. If that doesn't equal -1 -1, if it's not air, or self.bricks xp2 yp2 does not equal -1 -1, then we're going to set result equal to true. So what we're going to do is pass, if you look at our player character, we're going to pass 2 values which basically relate to the bottom of his feet here and here. We're going to say if either of those 2 points are on a brick, then he's standing on solid ground. That's going to be used for 2 things. One, it's going to say, well, then is he falling? He's not falling if he's on solid ground. And the other thing is he's allowed to jump if he's on solid ground. So that's our collision that is called on the instance of background. So what we now have to go here is create 2 points. I'm going to call them P1 and P2 again, which are the same. Now this is a different local P1 and P2, obviously. One of the reasons we're not using globals or anything, so there's no global statements, there's no confusion about whether P1 is global or these are local values, so they have the scope is just for this check and they won't be used again. And the same inside the method, the P1 and P2, there's a different P1 and P2, but for consistency we're passing them in. And now these are going to be points. They're going to be based on the position of the player, so self.pos0. Now the first point is going to be the bottom left of the player, so that's, we subtract var.player size 0 over 4. So we're going down, so that's 16 pixels essentially. In our 64 pixel image, his feet are about 16 pixels down from the center, and then we just have to multiply that by the scale. Now I think that's okay. I'm going to put brackets around this just to be safe. I think that it would be okay that it would take a quarter of that and then multiply, but just to be safe. And then we're going to use a very similar thing for the Y position. The Y position is actually going to be plus 1/4. Is 1/4 down. Sorry, this is the X position, so we're saying 1/4 across. So we're just going about 1/4. Anyway, the sizes are both the same, but for Y, this is where his feet are. And then we're going to do the same again for P2. But this is a plus now because it's bottom right corner, so the X coordinate is added. And then our collision check is going to be game.background dot collision dot collision, and it's going to take 2 points P1, P2. So we need to decide what we're doing based on that collision check. So what we're saying essentially is if that comes back as false, that check, so if he's not on solid ground and if he's not jumping, then he's falling, basically. So if he's not on solid ground and he's not jumping, then self dot is falling. It's true. And his acceleration in the Y direction is going to be equal to the universal constant of gravity. Now we need an elif here. And what we're saying here is now if you think about this, if these two conditions are true, he's not on ground and he's not jumping. If we have an otherwise, he's not jumping. So this is basically saying if this check here, game.background.collision came back true. So this is basically saying that if he's standing on solid ground, but it doesn't require another call to that game.background collision check. So this is in the case that he's standing on solid ground and not jumping, then we need to say that self dot is falling is false. Self dot acc 0 is 0. Self dot vel acc 1 that should be, and vel 1. So the y component of velocity and acceleration is 0 in the case that he's on the ground. He's not moving down by acceleration, or his velocity is not moving down. So we just need to work out how to do the jump now. And we're going to say if self dot is jumping is true, then his acceleration in the negative y, so upwards, he's going is going to be actually his acceleration is going to be due to gravity, so he's off the ground, because that first check would have failed, because if he's jumping. So we say that gravity is going to this should be equals. We don't need that equals, just self dot is jumping. And then we need a check here to say where is he in his jump. The jump is going to give him an initial upward velocity. Basically, when gravity has had such an effect that his initial upward velocity is now a downward velocity, so he's over the peak of his jump. Self.vel1 is greater than 0. So he's on his way downwards, because a positive y velocity means he's going down. Then we're going to say he's no longer jumping. Self.isJumping is no longer true. So basically this will come later when we need to do things like jumping into blocks and headbutting blocks. We don't want him to activate a block if he hits it with his head if he's not actually jumping. So if he's on his way down, he's not jumping, the block shouldn't be activated and such like. Okay. And the other thing we need to do in the update method is just increment the frame. Okay, so we just really can't, there's nothing to show as yet. We've got all our updates kind of in place there. We just really need to do a draw image. And now for 5 parameters, remember the first one's going to be var.playerImage, then there's going to be 4 lists after that. Now the source center is the first one. We'll come back to that in a second. The source size we know is going to be var.playerSize, that 64 by 64. The destination position is going to be self.pos0 minus the camera. Remember, var.camera. Only the x has the camera applied to it. The camera only moves in the x direction. And then self.pos1 is going to be the y position. And then we know the size, that the destination size is going to be var.playerSize but scaled. 0 times var.scale and var.playerSize 1 times var.scale. Okay. So the source image, if we look back at our source image, we need to know what he's doing. If he's standing still, it's 0. If he's jumping, it's 1. If he's falling, it's 2. And if he's running, it's either 3, 4 or 5. Okay, so just have, before we do the draw, we're going to have an if, else for those 3 conditions. So first one, if self.isJumping, then his x position, we're going to set x and y values for the position in that image. If he's jumping, his x position is going to be 1. If he's falling, his x position is going to be 2, and that should be just. And then if he's moving, we're going to set that self.isMoving on the go left and go right methods. So if he's moving, then x we want to equal either 3, 4 or 5. So we want 3 values for x. So we want to base it on the frame. So if we take the frame and divide it by 10, so this is going to change every 10 frames. We want the number to come back as one of 3 values, so we use %3. And then the 3 values, instead of 0, 1, 2, we want 3, 4, 5. So that's 3 more than 0, 1, 2. So that's our formula. So divide the frame by 10, so it's every 10 frames it's going to update that value. It will be 0 when that frame is from 0 to 9. It's going to be 1 when it's 10 to 19. Okay, the final else then, x equals 0. So if nothing else is going on, we're just going to use the first image. And then we're going to set y equal to self.direction. So now we have an x and a y, and because we chose self.direction to be either 0 or 1, 0 for right, 1 for left, we now have an x and a y that equates to the position in this image. So we just need to scale that now, multiply it by the size and add a half for each. So it's going to be x times var.player size 0, and then plus half of player size to get the center of the image. And then the same for y, except player size 1. Okay, and this is quite a long line, so I'm just going to cut it off here and make it sit on there. Okay, so we're at a point now where we should be able to test this code. I'm going to open up a Codeskulptor window. I'm going to paste in the code and just run it. Okay, and there we go. I'll just show that again. This is our initial position we gave, velocity we gave our player, and then he comes to a rest. Now it doesn't, there's no key handler set up yet, so nothing doesn't do anything, but it looks like it's looks like so far so good. So back to Visual Studio, and what we're going to do now is just add the key handlers. GUI.frame.set underscore is key up handler, I think that's right. Then we're going to call GUI.keyUp, and then for the key down handler, GUI.keyDown, and then we're going to just create some methods here, some handlers. Key up, key, key is simple GUI dot key map. I think it's key map. Let's look at the documentation. Yeah, key map is uppercase, I thought so. Map. Then key map is obviously a dictionary, by the looks of it. And then so key map left first of all, then game.player go left. Okay, and we just need to repeat that 3 times for left, right, and space. And it's going to be left, go right, and jump is for space. Then one last key down. So if it's left or right, we want to basically call stop. So if either the left key or the right key comes up, we want the player to stop. and I just realized these are methods, so they need brackets. Jump, go right, go left. So just one last thing really to do, and that's just these 4 methods here: left, right, jump and stop, just to set those up. And they're actually very simple. All we're doing is going to say, first of all, we say self.moving is true, self.isMoving, true. This lets our animation just above, we know which, if he's not jumping or falling and he's moving, then we know which to go. And then self.acceleration 0 is self.rate. So let's just check that's the right value. Yes, self.rate, the right variable. And actually it should be minus self.rate because he's going left. So we also need to set the direction there. And left is 1, so it's the bottom line. Okay, and then we can just copy those and tweak them to go into the go right method. Direction is 0, and it's not a minus on that, so it's plus self.rate. Now for the jump, we actually need to do the same test to see if he's on solid ground, otherwise he'll be able to jump when he's in midair. So we need to test that he's on solid ground and then fire him upwards, set jumping to true and fire him upwards at some velocity in the minus y direction. So what I'm going to do is I'm just going to copy this code from where I did the collision check before, because we're going to use it pretty much the same code. We don't need to check if he's jumping. So what we want to say actually is not, there's a not, we want, if that comes back with true, we want to say self.isJumping is true, and then there, give him some velocity in the upward direction, which is minus, self.val1 is a minus number. And we'll say 20 just to, for the sake of having a value in there. And then the stop, this is if the key comes up, we'd want to say self dot the 0 component velocity of acceleration, that should be actually, shouldn't it? 0, so stop accelerating. And then for the sake of the animation, we need to set self.isMoving to false. Okay, so we're going to copy all that back into Codeskulptor. So we've got our player on our background. Keys aren't doing anything. Okay, interesting. I think maybe we made an error in setting our key handlers. Yes, key up handler and key down handler should be. I've got key up handler and key up handler, so it should be key up handler and key down handlers. I'm going to just edit that in Codeskulptor. Oh, okay, something weird what happened there. I'm going to put all this back into Visual Studio. I'm going to go back to Codeskulptor. Just I'll try running that again. Having a few performance issues on this machine. It's kind of a little bit low on RAM, I think. But okay. Let's try that again. Okay. Okay. I'm going to save that in Codeskulptor. And I'll stick this URL up with the video. I think we're done there. I think we've covered a lot of ground. It's quite a long video, 40 minutes, so hopefully useful. And you see that the game can take shape at this point really quickly, and there's only really kind of graphical and audio bells and whistles to add onto it, and there's kind of a fairly decent game there. There's lots of different things could be done. The Y direction of the camera is one thing that you could add and give a kind of vertical component to do something different. Okay, so I'm going to sign off. Thanks very much for listening. This has been part 2 of my series. I hope to record 3, 4, and maybe 5 fairly quickly in the next few days, and hope to see you on the forums. Thank you.